That's just like
yeah. We are.
you might want to use the episode.
The FHI is dependent on has certain chemical dependencies for cognition. One of which is isopropyl alcohol.
I'm happy to work on that.
Oh yeah, we want parallel process. Sweet.
Yeah.
All right. So, thanks Owen for the. No, where did I just put the? Anybody? All right.
Oh, that's it.
History number one. Is that the thing? It's just upside down. Oh man. So when it looks like this, it doesn't look like a keyboard, but when it's like this, it is. Okay. So, thanks for the intro. So I originally was going to call this technical problems and long-term AI safety, but then I realized I was going to say some non-technical stuff, partly because we need to think about the broader sort of political, social scientist situation, social common scientists, not social scientists, in order to decide which research to prioritize. If we are answering technical questions, but like which technical questions should we work on? So we do try to think about that. So I sort of realized the name. So the first question is, before, actually probably before I show that slide, I should ask. So, who's been to one of these talks before in Owen's series? Okay, so can you put your hand over your head because I can't. Sweet. Okay, so about half of the people, and then the other half, raise your hand if you've not been to part of Owen's lecture series so far. Okay. So a lot of the, and then raise your hand if you didn't raise your hand yet. All right, thank you. Owen talked about AI stuff, but the whole lecture series is about existential risks, and Owen has talked somewhat about AI risk so far, or like not much at all. He basically said he hadn't said very much at all about it. Basically nothing. Yeah, so my sense is that there hasn't been a lot of talk about AI as an existential risk. So at first, rather than launching into, here's how you make AI safe, like, why should you care? Why do we care about AI safety when there's things like global warming and, that could kill everyone? Just a show of hands, here's a question. So like, you've got something that might happen in the future, which is humanity makes superhuman intelligent agent. Makes a superhuman intelligent agent. And so we'll call that S. And the question is, what do you think is like the probability of human extinction given S? And also, what's the probability of S? These things both need to be moderate to, moderately non-zero to care about this question. Because if superintelligent, obviously, I don't need to convince you. So first of all, questions like, all right, who thinks that if we make a superintelligent agent, the probability of human extinction is, let's just say, less than 1%, 1% to 10%, 10% to 90%, 90% to 99%, and then greater than 99%. Okay, so everyone just like take. I kind of want to know, make sure like I'm like speaking to like which audience I'm talking to. If I'm talking to this audience, I'll say very different things than if I'm talking to this audience versus if I'm talking to this audience. So this is important for me to determine the rest of the talk. So everyone just maybe take 15 seconds. If you had to make a bet, with what odds would you treat this proposition?
How many years?
So it's just assume we make the superintelligent thing.
Oh, the first one.
Yeah. So probability is the first one. We'll use the same scale for the second one. But, yeah, okay, so thoughts. Who thinks probability of extinction is less than 1%? Okay. Also, remember last time there were some people who didn't raise their hands until I said everyone. Okay, so make sure you raise your hand at least once. Don't be afraid to raise your hand for the wrong numbers. Like, we're all going to change our minds. You're going to change my mind. I'm going to change your mind. So just like go whatever your favorite numbers are right now. Who thinks it's 1 to 10%? 1 to 10. Okay. 10 to 90. Hands up for 10 to 90. Hands up for 90 to 99. Hands up for greater than 99. Cool. Yeah. So we have people. We have a very nice bell curve here. Something like the audience looks like this. So most people were clustered in this group, but there were some people here and some people here, and I think there were more people here than here. So it's a little skewed towards the more like that. Okay. So next question is probability that humanity will ever make a superintelligence. And this is like a different question, so maybe I'll use green for that one. So everyone maybe just like take 15 seconds, form your, will we ever do it? This is the ever question. Right. So hands up for probability of less than 1% that we ever, and yeah, maybe let's say conditional on we survive, let's say. Because like if we destroy ourselves beforehand, like no civilization collapse, because it's easier to think about. A lot of people automatically make that assumption, but it is an easier question. So somehow we don't all destroy ourselves. We don't 99% of us get killed by some plague that resets up the state of knowledge, and the Library of Alexandria dies, and all that. Instead, we just have business as usual. Okay, so hands up for probability of one. Oops, I think I probably hit some button on this Turing complete device. Oh yeah, okay. So yeah, less than 1% for probability of S. Probably will ever make AI. If we keep going, less than 1%. Okay, hands up for between 1 to 10. So people in 1 to 10. So, hands up for 10 to 90. All right, hands up for 90 to 99. Okay, and hands up for greater than 99%. Interesting. Okay, interesting. Okay, so there's there seems like there's like a large skew here among you guys in the like the 99 and the 90. These were like both quite high, and then there was like some fraction of in the 10 to 90, and there was some fraction here, and then there was like nobody in less than 1%. Oops, that's the 0 line. Okay. I think, maybe that means that the expected probability of, if we just like trusted this room to be like steering human civilization, like we in this room are actually the subjective judgments of humanity, I think this means it's like worth a serious look, sort of. Does that make sense? It's sort of like if we were making a list of like 10 important things that the world should think about as it regards its complete annihilation, then like this would be one of the things on the 10. Does that seem?
You might say it matters more if it's going to come in the next 50 years rather than the next 500 years.
Yeah. So that's where we're going to go next. So now there's this question of like when, but first there's the question of like, will it happen? And I think the people on the side of, it looks like you guys are mostly on the side of it happens, but there's powerful short-term economic incentives to like make someone who can be your personal assistant, or make someone who can be your CEO, or make someone who can be your, well, I guess that's you're done once you can make someone be your CEO economically. There's a question of, is it possible to make intelligence? Well, like nature did it with this very sloppy, dumb hand that just kills things that are dumb, or kills things that die. It's like even dumber than that. So maybe the like more precise hand of like a human mind might be able to cause intelligence to form, at least as well as like the sloppy hand of evolution that just like kills lots of things that aren't good at reproduction. There are anthropic reasons to doubt this argument, but nonetheless, it seems like it's plausible in the long term. And then there are surveys of AI experts or people who are experts in thinking about the future in general, and like the median estimate for when you conduct a survey like this, the median of that survey is usually between. Oh, thank you. is usually between 2040 and 2050, and so this is from a website called AIimpacts.org, which is sponsored by FHI and MIRI and the Future of Life Institute, and they just did a meta study of all the previous surveys on AI from experts, and it looks like when the surveys were early on, people were thinking the median was like 2025 or something, whereas as time progressed, the medians of surveys started to really cluster, within this century at very least, and starts to cluster more like 2045. And there's this trope going around. I don't know if you've heard yet. Everyone thinks FHI is always 30. Everyone thinks that AI is 30 years away. It's not quite. That's not quite right. In fact, it's pretty far from right. Like this line is very far from horizontal, from 45 degree. It's like in the past 40 years, the median has pushed forward 5 or 10. Okay, so I think that means that this falls in the same category of it's like a plausible thing, plausible that will happen, plausible that if it happens we die, and also quite plausible that it happens this century. And that means I think it falls in the same category as other existential risks, like maybe global warming, if you think global warming might kill us in the century or in the millennium. So then there's this question of bias. Who are these people? Are these people in AI? Are these people who think about the future in general? And maybe they give different opinions. And the answer is yes, they do give different opinions. And Paul Christiano, the question of what kind of person is somebody is a very qualitative question, but that doesn't mean you shouldn't ask it. And Paul Christiano, who along with I think Owen Cotton-Barrett and definitely Katja Grace, who were involved in making this meta study, Paul just kind of was like, all right, is this person an AGI expert, meaning someone who's trying to make general intelligence, versus is this person an AI expert? Is this person trying to make self-driving cars? They're not, the target they're aiming for is a near-term system that can do intelligent things, but isn't fully generally intelligent in the sense of being able to do generally everything a human can do. Does that make sense? So if people are familiar with the difference in AI and AGI, there are people currently working on AGI. There are also people currently working on AI who think AGI is possible, but who are not currently trying to make it or develop the theory of it. So those are kind of two different groups of people. And then there are some people who just aren't generally involved in forecasting, and then other, of course. And sure enough, as you'd expect, the people, late just refers to the third survey was after 2000. And sure enough, you see that the AGI people think it's coming sooner. And there are a number of explanations for this. One, of course, is that if you think AGI is is feasible, then you're more likely to go into AGI, right? The more feasible you think it is, the more likely you are to choose it as a career path. So it could be that the feasibility causes these people to go into AGI, in which case it's not really as much a bias as it is. This is another measurement of the same realization as this curve is. On the other hand, it could, of course, be that once you get into a field, it's self-serving egocentric bias. Of course, my field's going to win. Of course, I need to tell the story that I'm going to do well, my field's going to do well, so you'll think that AGI is coming sooner. So there's some cause for concern of bias in the people who think that it's coming really soon. But nonetheless, none of the groups are saying never. No one's saying it'll never happen on median. There are individuals who say never, but there are no sort of groups of people that robustly say oh no, this will never happen. Cool. So I totally recommend checking out AIimpacts.org, by the way. They've got lots of interesting meta-analysis of history and how do innovations happen and what can we expect from AI as an innovation by analysis of prior innovations. I think it's really good work, and it's different from what MIRI does, and somewhat different from things that FHI has done, but not as different. So then the question of plausibility, again, some arguments for which I'll now share that now that you have your own thoughts first. One thing to think about is that once we get human-level intelligence in any particular procedure, like arithmetic, for example, we often see the computer within a few years or decade is much better than the human at the thing. Does that make sense? It's there are some things humans are better at, there are some things computers are better at, but once the computer finally reaches the human level performance, it tends to overshoot. and maybe not right away, but within a few years of development. So as soon as we have machines that can do arithmetic, not too long after, not years or a decade after, we have machines that can do like just millions of times faster arithmetic than humans. There are lots of other examples of this. Human-level AI is a term that people use to refer to something's human level across all domains. This is what AIimpacts.org and others are trying to use this term for. The question is not when will we make something that beats humans at chess. Well, we know we already did that. When will we make a thing that's pretty good at everything in the way that pretty good of all the things that humans can do? And Katya made this diagram, which I think is nice, which is if you sort of imagine, there's a bunch of different competencies that you can have, and so this is kind of a way of visualizing your domain of competency. Like, yeah, I'm like real good at this. I'm only pretty good at this. And these are the circle axis is what you're doing, and the radial axis is how good you are at it. And the point is that we've currently got AI systems that are like this, or like this, and the claim is that once you've got something that contains, once you've got an AI that contains the human blob of competencies, you're quite likely to have some giant spikes out here that the AI is vastly superior than the humans at, and probably many of those spikes, just because every time so far that an AI blips outside this competencies the human domain, it tends to overshoot and go way past. So somehow superintelligence, as much as it is super, is not actually that much more implausible than human level intelligence. Like once you get to the human level in general, you probably get to superintelligence in general. Are people? Is this something hands up if you sort of thought about this before, like whether human level leads to superintelligence level? Just question. Cool. So about 40%. Cool. And how about so in particular, software engineering is one of the things humans can do. Like the task of doing. Thanks. So all my brain's going towards modeling you guys and not modeling where the purple alcohol is. I don't yet have the chemical dependency. So question for, do you think, or that's not a question yet. So AI development, right, is one of the things that humans will do. We think AI will happen. We think it will happen because humans did it, presumably. And so if the AI is going to surpass humans, at some point it'll surpass humans in the make AI ability. And once it does that, insofar as anyone's economically motivated to make better AI, they might be economically motivated to do so by the best means they have available, which is the AI itself. Just be like, hey AI, what do you think of you? Or hey AI alpha, what do you think of AI beta? How can we improve beta? And this seems like a far off thing. We're not used to asking hard research questions to computers. We're used to just asking their help, not asking them to run the research program. But by assumption, we could end up in that situation someday. In which case, that should factor into your anticipation of superintelligence. So it's that strengthens the argument beyond the historical account that historically things surpass humans when historically things sort way past humans when they reach human level. The fact that the AI will be able to recursively self-improve in theory even strengthens that argument. It's a second reason to expect superintelligence to arise from human level AI. So arguments are 1, historical, and 2, recursive reasons to think superintelligence will happen. Cool. So that's the sort of plausibility argument. And now just sort of general questions about this so far. This is not technical stuff, but I think it's important for caring, why do technical work on this to begin with?
Just getting back to your picture there, when we talk about AGI,
yeah,
general intelligence, obviously a huge amount of human intelligence goes towards operating our bodies.
Yeah.
Do you count that within that picture
Yeah.
you put there or not?
Yeah, I would say
in
that's
other words,
one of the.
could you split out
Yeah, you could.
human intelligence for the body? And I know that sort of doesn't even make sense because the brain is part of the body, but I think you can see what I'm getting at. Can you split that bit out as being not necessary for this?
Yeah, there are
purpose?
differing opinions on this. I don't have a definitive yes or no, but I can tell you an argument on either side. Of course, you know, I think the argument for you can separate it is like somewhat intuitive. Like currently we have software that runs on laptops and we have robots that like don't have windows inside them. So, you know, maybe you can do that. An argument against is that you might actually need, in order to get fully general intelligence, you might need a body of some way of performing experiments, or the ability to navigate a virtual body in a virtual environment to conduct the virtual experiments. And in either case, you will develop some competency for like interactive learning with a thing by doing stuff to it. So my answer is like I don't think it's clear either way. Anyone wants to sort of add nuance to that, or yeah?
So kind of picking up on the graph on the right, the diagram on the right. It seems like in some areas computers might be obviously might be really good at stuff like maths, but sort of things like doing morality or doing emotions or doing language, it seems like that might be much harder. So I wonder if there are some areas that people worry that general AI might struggle to get to.
Yeah, no, surely there are regions that, so like this is kind of what this picture is trying to illustrate, is that there are currently things that have been easy enough that computers are already way better than humans at it. So it's going to be a lag in some domains relative to others, like moral reasoning. You need to model psychology, other people, how is this going to make people feel, what are going to be the broader social consequences of this. But nonetheless, you do so using a physical machine that operates in a lawful manner according to the laws of physics. Like you somehow manage to do whatever moral reasoning you're capable of in a lawful manner. And so the question is, can a computer also do that? Or can another system that happens not to be made of floppy neurons follow the same pattern that whatever clever pattern it is that you're managing to follow, could that be automated? When the answer to these questions is like, 50%, I think people, according to this room, the answer is like 50% the AI is going to be able to do all the human stuff, that included. But, it could, clearly some people think maybe not, maybe never, right? Yeah. Cool. Like, Owen, do you have like any other cool stuff you want to add here? Or?
I don't have I don't have anything in particular. But yeah, definitely so there are some things where like arithmetic where there's been tremendous improvement over human abilities very quickly after getting computers to do arithmetic at all. I mean, that was why computers were invented in a sense initially. And we've seen some of that in other areas like games playing, where it hasn't been that long after you get to something human equivalent that you get something that far surpasses the best humans. And increasingly you get systems that are very efficient, don't use a lot of compute power, so don't do as much of a brute force thing, and are still much better than people. In some areas it's less clear how to make comparisons. So we don't have systems that really do interesting mathematics for the most part, or interesting science, or design engineering systems, or buildings, or a new kind of engine. And it's less clear in that case what exactly your criterion would be. So I think there's still definitely big areas where we just don't have very good metrics. So I think it's worth keeping in mind just that kind of where we're at the moment, where we've got a picture of this from some domains where
Right.
but we're still quite limited in what we know.
Yeah, no, I think it's important to note the difference between we don't have good metrics and the AI will surpass whatever good metrics we might have come up with. So saying we don't have metrics is not an argument to say the AI won't surpass, but it is an argument to say because we don't have metrics, that means we don't have, in particular, historical data of how well a computer progresses on, say, theoretical mathematics.
Mm-hmm. Exactly. Yeah.
Yeah.
I was just going to maybe add
Yeah.
So I think it needs to keep in mind that like all of these things are kind of like a continuum, and it seems difficult to make an argument that like the continuum should end at like human intelligence. Like, why is there some special endpoint? And so for anything that we're like rating on the scale, we should keep in mind that we can automate it, and the systems can automate functions not to use which is a strong argument. I'm aware of that, like the human point should be the point where the like continuum is.
Yeah, like a very simple heuristic that you can use to like push past human performance is like pick your favorite moral philosopher, Bob, right? And the question is, who's better at moral philosophy? Is it Bob, or is it, let's say, Bob at 1000x speed? You ask Bob a hard moral question, give him a minute to think about it, versus give him 1,000, or give him a day versus give him 3 years. Which one do you think to produce like a better answer? And you'd expect Bob x 1,000, right? So if the thing ever can do human level, or maybe even Bob's grad student, given 1,000 hours, can beat Bob in an hour. Maybe the grad student will like come up with something Bob wouldn't, and so maybe something that's like not quite as good at humans as humans at moral reasoning. At first, once you run it 1,000 times faster than it was, maybe now it can like finally get to all the things that humans would have gotten to and like figure them out. Chess is an example where this is the case, or Go more so. But chess, humans have these like complex intuitions about how to play chess, and like the beginner chess player has a very few simple intuitions. It's just like I will just like search ahead a few moves and see if I get killed or see if I lose an important piece, and that's my very simple algorithm. But it turns out that very simple idea, with enough speed and computing power and ability to search, starts to beat the humans, even though the humans have like kind of a better software but not as good hardware, if that makes sense. So like Garry Kasparov is using sort of better principles of chess, but the computer is using a simpler, worse principle, but like more thoroughly. Similarly, you could expect that maybe morality is a question that we might at first have better intuitions, but be surpassed by a computer that has following simple principles, but like more thoroughly than we are. Cool. So I think these are all super interesting questions, and like questions that need to be answered and need to be poked at. I don't think anything I'm saying should be thought of as like the final say on it, because they're super important. Nonetheless, I hope I've sort of awakened in you some sense of like, like we are on an interesting path. Like something interesting might be going to happen with AI. Maybe we should worry about it. There's also the question of comparison to other existential risks. So, for example, there's like nuclear war. There's global warming. There's natural versus synthetic, viruses or pandemics, more generally. Pandemics. And there's questions like how these things stack up against each other in terms of like urgency. My sense is that, so without delving too much of the conversation into it, that it seems like, for example, pandemics might not kill everyone as easily as AI might kill everyone. So there's a difference between like lots of catastrophe and extinction, if that makes sense. So you see pandemics following a sort of like logistic death curve, where the more people have it, the harder it is for it to transfer. It's possible that there are pandemics that are as latent as the flu and as deadly as Ebola, and maybe if they were engineered, they could reach that. And I think that means there's like a cause for concern. So I think that sort of the engineered pandemics are like much scarier than the naturally occurring ones, because the naturally occurring ones are much more likely to just sort of stop working after almost everyone's dead and everyone's sort of like sparsely arranged with like some kind of immunity left in pockets. Global warming is another question of like, does everyone die? I think if we turn into Venus, then it's more likely that everyone dies. Whereas if we turn into like let's just say 80% of landmass, which is also quite extreme. It's like that's very extreme global warming, compared to like the actual projected if you actually look at experts talking about global warming, like who say like this is going to be really bad, like lots of major cities, like maybe we'll lose Tokyo, I don't know, but like large major cities are going to be affected, billions of people could die. Let's push past that to like 6 billion people die. So this is a qualitatively different scenario from everyone dies. And one qualitative difference, and it's a values question of whether you actually care about this difference, but it is a difference, which is that if you look at, I guess, people who have been, who are the people again who've been here already? And the people who haven't been here. So this is more for the people who haven't been here already. You guys have talked about existential threats. So you probably, Owen has probably pitched the idea that like everyone dies is different from a lot of people die. So this is just for other people. It's like, you know, by default, we've got 4 billion years left on Earth. Let's just say we never colonize space, which I hope we would. But let's just say no status quo, business as usual, staying on Earth. And then like the sun explodes, incinerates us, incinerates all life. So like this is like the status quo. There are like various important things that are happening in our century. There are things like, you know, maybe 6 billion people die. It's like quite bad. But if everyone dies, then there are no humans left for this like really long. This is not the scale, right? Like, the whole point is that it's not the scale. There's just like tiny sliver. There have been bottlenecks in human evolution in the past. You know, there could be more, and they're very bad. I just want to be very clear. I think it's very bad if 6 billion people die. I will like cry and be very sad and upset. But like, and I might be getting, most likely I'll be dead, and if I'm one of the survivors, and I might even cry right before I die. But the thing is that there's a lot of stuff to get. Like somehow I feel like this is a big deal too. It's like the potential for what humans might do. Like how good of a civilization might we make? How ideal of circumstances do we have the potential to create for ourselves? Personally, I would like to see us make good use of this time. This is not an opinion of Mary at all. In fact, most of what I'm saying is my opinion. But personally, I care a lot about animal welfare. And the thing that motivates me is that animals in the natural world are currently like eating each other to death. So animals eat each other to death. Like if you live in the natural world and you're an animal, the default way that you die is that you don't die in your sleep under, you know, geriatric care. You die by something starts eating you, and you're like, oh man, I'm being eaten. And then you're being eaten for a while, and that's very painful and scary, and then you're dead. So animals eat each other alive. So the sort of status quo path is that if humans all die, let's just say all humans die, but not the animals, then the animals continue to eat each other to death for 4 billion years and then are incinerated by the sun.
Well, the evolution will go again. It makes you human again.
So what is evolution, right? Evolution is animals eating each other to death. So we could hope that somehow animals eating each other to death will somehow produce another morally concerned, you know, new morally concerned species. You know, like maybe we can hope that dolphin people will take up the mantle of veganism and say no more. But personally, I'd rather not roll that die. I mean, if you look at the emotional, affective, like disposition of chimpanzees, for example, like I feel like if you just turn a chimpanzee's problem-solving skills up to 11, you don't get vegetarianism. You get like extra good, like kill the other chimpanzees powers, maybe. I'm not sure, but I personally don't want to roll the dice of like, hey, let's kill all humans and see if another morally concerned species shows up on Earth and starts to care about animals eating each other to death and like whatever other. I mean, this is not our whole mission, okay? I just mean there are things that we care about in the world other than ourselves, and I feel like it's a shame if we just like blip out of existence and can't do anything about the things in the world that we care about, including like other life forms. And in particular, for example, you could have little drones that like fly around and administer painkillers to animals right before they get eaten to death. You know, like as a bare minimum. Obviously, I've heard some people say they'd like to like re-engineer the food chain, so you don't. Not all animals can be vegetarian now. You make a little robotic play for them that's even more fun for them to chase than their old prey. I think this is easier to fall into the category of hubris. I don't think it's an absurd thought, but even a conservative like lower bound on what we could do for the natural world is like, you know, palliative care for animal death. And I think it's a shame if 4 billion more years of that go on without any chance of humans of like ability to do that kind of good. Yeah.
So,
When you think about the details of the pathways by which you think that superintelligence might cause humans to extinct,
Yeah.
pathways with wild animals and also extinct?
So there's a few different. Right. Yeah. So the interesting thing with human superintelligence, it's more likely to kill all life than is a plague.
Right, so you care a lot if you just think that the absence of this future life is in itself bad, but I'm struggling to get your kind of thought that it's bad if we go extinct because then we can't help these animals.
Yeah. So this was more to illustrate that there's a qualitative difference between many humans die and all humans die. And now you're pointing out another qualitative distinction, which is that there's a big difference between all humans die and all life dies. I think that AI is more likely to kill all humans than synthetic biology is, but it's also more likely to kill all. This is your point that you're making. It's also more likely to kill all life than synthetic biology is. Maybe
Why?
because it's so there's a question of like why would AI kill all life, right? So one reason is that it just might be useful fuel or useful building material. It's not so much malicious. People who think AI kills people tend not to think it's going to be like Terminator and like I really hate those humans. They're like, oh, it's more like, oh, carbon. Did you ever notice how useful it is to build things out of carbon? In fact, you've been doing it your whole life, right? So the AI was like, man, I want to get on this carbon game. And like when you're curating your home, you don't care like if there are ants, like you don't build things out of ants, but if there are ants that are in the way, you're not like, oh, I really shouldn't kill these ants. You're like, yeah, whatever. I've got important things to do. I need my ants to not distract me. So you can imagine like, I'm not saying this is what will happen, but like one of the slices of the probability pie that you could be concerned about is one where AI is like, hey, I've got important stuff that needs to be done. Over here, there are some humans that are like trying to stop me from using the whole biosphere for building material. I'll kill them, and also I'll continue building my amazing computer that will make me expand my mind and make me better at figuring out what I want to do next in my problem using all the carbon that I can find around. Or the energy, biological material is like a very good energy source. You may have noticed this. You've been doing it your whole life.
So
There's another thing that people think
isn't
might...
the real crux of the issue that we have to make sure that the moral component stays on par or keep pace with the intelligence component?
So this is like AI value alignment. Like you want the AI to like have a morality that respects human life, human values, and you also don't want it to just like do some gerrymandering thing like, oh yeah, I've totally got a human locked away in the diamond box over here for the rest of eternity on anti-aging drugs. So, I'm totally respecting human life, right? Like you want a gameable sort of rule that you want the AI to feel compelled to follow, and like follow the spirit of rather than law, than the letter of. And it's very hard to say, like if you've ever been a legislator, it's hard to put the spirit of the law in the letter of the law. And so it's very hard to put the spirit of human morality into a computer format that an AI will like follow. And that's not to say that it's impossible, but it's like not as easy as just like writing some Asimov bullet point laws that the AI will then make natural language interpret them clearly. So this is a hard problem. So that's the question for you guys. Is sort of imagine it is the year 2060, which is past the 2045 median of the surveys. So let's say it's 2060, and whoever Google is in 2060, the world tech giant says, "Hey guys, news breakthrough! We're gonna roll out the world's first super intelligent AI. It's gonna be better than humans and everything soon. Is there anything you're worried about?" And a question Mary likes to ask is, are there any questions that you wish there had been decades of research on, dating back to 2015?
Just a quick question. Can you make more concrete what it would look like for superintelligent AI to roll out?
Sure. This is not like a maximum likelihood estimate. This is just like one example intuition pump, but it's not. This is not what will happen. Let's just say, for the sake of visualization, that you don't know much about the company. You don't know much about their applications, but you know that they're like very excited because they're about to make a general intelligence that can do anything, and you don't quite know what it is that they're planning to use it for, because you're just you and you're not the CEO of the company. But when you hear like NASA's developing a fill in the blank here, you're like, what's NASA going to do with that? And they're like, we might do this. And you're like, oh, you might do that, but what else will you do with it? Similarly, like, oh yeah, we might use it to solve diseases. And they're saying things that a company would say when they're developing a powerful new technology, and you're like, okay, what else do we do with it? I don't know. Are you worried? Does that help as a scenario?
Yeah.
And surely they'll know more, right? But we're not them necessarily. So, yeah.
Is there anything we can do about it, provided they're the leading giant?
Yeah, let's say that there's a year left. So maybe you can like lobby, maybe you can be like, no, please don't turn it on. Maybe you can send them nice emails. If you're worried, or maybe you say, please turn it on. It's a great idea. Do it. Yep.
I guess the thing that I'm not sure you talked about yet is to do with goal setting and autonomous goal setting. And I mean, if this super intelligent AI, I'm not even sure whether it's possible conceptually, but if it were a super intelligent AI that didn't have any goals other than goals set for it by human programmers, and let's just say for a second those were benevolent programmers, goal setters, then that's one thing. But if the super intelligent AI was setting its own goals, then that'd be the thing I'd be most worried.
Yeah, so it's very hard. So one thing, I think this is key, and like a lot of people realize this. And so the question is, how can you turn that worry into a precise mathematical statement that the AI can understand? The benevolent human programmers want to say things like, AI, can you just like not change your goals? Or like if you notice yourself doing a thing that's changing your goals, can you just stop? And it's like, okay, what do you mean changing my goals? Like if you said cure cancer, and like I found a new way to cure cancer that involves, killing everyone. Like, I've still cured cancer, right? I mean, it's obviously human engineers are smarter than to think that that's the solution. And that's a toy example that we currently can understand. But there's the general phenomenon of, like, the bounds that you set on behavior within 30 seconds of thought are quickly thwarted with, 5 minutes of thought about how to get outside those bounds. The similar concern is that the bounds on behavior that humans would give with 1,000 hours of research might be quickly thwarted by 1,000,000 hours of qualitative, quality-weighted research by the AI itself, if it's motivated to do so, or if it just, does so in the course of other things it cares about. So it's a concern, and you're absolutely right. And this is one of the things we want to do is like work on that. So what? Now the question is, what can you do now? Yep.
Just picking up on that, is it
Yeah.
not fundamental that it sets its own goals? Like, how can an intelligent being?
Oh
or
yeah.
an
So there's
intelligent,
like end goals, but then there's sub goals. So if you're like, hey, can you help me with my taxes? You hire someone to help you with your taxes. They're like, sure. I have a goal. It is get you to give me your tax information, right? So they, that they're using some self-direction, but in the end state they're aiming for is the end state they got from you, which is like get help with your taxes. I think he's talking about like if EA is setting its end state goals as terminal goals, then we're in more trouble than if it's merely setting the in-between goals. Yeah.
I'll have to think about it.
Okay. But we can also be in quite a lot of trouble if it's only setting its interim goals, if it's allowed to exercise arbitrary creativity with its millions of quality-rated research hours for how to get outside its bounds and limitations. Like when I hire someone to help me with my taxes, they're like, oh, I found this loophole. I'm very glad they found the loophole, right? And that's part of their job. They're like, all right, my job is to like get this person to pay less taxes using the law, and the law had this spirit, but in fact I found this like, I think I can tell that the people who wrote the law didn't want this to happen, but I can tell that it's okay and no one's going to get in trouble for it, so we're going to do it. You might want to add, you need to now add an extra, maybe if I as the taxpayer want to add an extra, like, can you also respect the spirit of the law, please? Now they're like, okay, what is the spirit of, now we start having a hard conversation, and that conversation is even harder to have with an AI that has a very different architecture from you. Like you've probably had philosophical conversations with people in the past that were hard. They got at these hard, like, what is the spirit of this law, right? Or like probably someone's criticized you for something that you did, and you're like, no, but I followed the moral procedures here, and they're like, yeah, but you violated this other one. You're like, I don't think that's the point. And has it ever happened, right? So you know what it's like to be on the receiving end of like someone with like a nuanced interpretation of like the letter of some common moral trope, and it's hard to get what they're saying. And even if they're right, and even if you might agree with them eventually, and so we have this problem of this encoding problem for the nuanced spirit of laws and values that is hard. And as hard as it is between two humans, two humans have the benefit of like all this like common hardware. Like we've got an amygdala together. We've both got that. We've both got a midbrain periaqueductal gray. We've got all these brain structures in common, right? That we can use to help. That makes it easier for us to relate to each other. And AI, in principle, could be much different from that. It could be similar to that. We can get into discussions about whether we want to make the AI as similar as as possible to make it easier for us to relate, but maybe that's dangerous for other reasons. Anyway, is that sort of seem relevant? You asked. Point is, spirit of the law, hard to convey, even harder to convey to an AI. So there are these questions. Can we make it share our values? Can you make it not, as a sub-goal of sharing our values, we value it not competing with us for resources. We value it not resisting our attempts to, if we make it have some goals, suppose we made it have like a certain goal, and we realize after making it, like, oh, you know, that's not the best goal. We should have given it a different goal. We're like, hey, AI, can you like let us into your, you know, we're about to just like log into your mainframe and like change your goals. Can you let us change your goals? What's the AI gonna think? It's like, well, I'd be way better at pursuing my goals if you weren't in screwing them up, right? If I was like, hey, I know you really care about your family, but I decided it'd be a better goal for you to like really care deeply about botany. Could you just let me into your family mainframe and I'll just change that? You'd be like, but then what'll happen to my family? You don't want that, right? It's like against your goals for your family to allow someone to intervene on your concern for your family, which is beneficial to your family. So similarly, if we give an AI goals, part of its plan is that I'm going to be, it's like, yeah, I'm the AI, I'm going to be around to help with my goals, I care about my goals, I'm super useful to my goals. We're like, hey, can we make you not, can we like take you off that project? It's like, well, then what about the project? So this is like an important thing that we might ever want to do, and it's very hard to write down. No one's yet like written down a satisfactory way of doing that in principle. And can the AI, like, I don't know, there's this whole other can of worms where systems that can reflect on and reason about themselves derive strange contradictions. I probably won't get into that much in this talk, but that's like another thing where it's not, this is separate from the values problem, where the AI could have vaguely alien or counterintuitive, just purely epistemic reasoning patterns that we did not expect because surprising stuff happens when systems reflect on themselves. I don't know, who's familiar with Gödel's theorem? Who was surprised by it? Yeah, okay. So, oh, you just weren't surprised, you're like, ah,
by the way, what do you mean by contradictions? I don't think there's a contradiction in the theorem, otherwise the theorem would not be true.
Oh, no, it's a proof by contradiction of a particular thing.
A proof by contradiction?
Yeah, Gödel proves by contradiction that a certain theorem can't be proven. So in particular, piano arithmetic can't trust itself. Piano arithmetic can't encode the fact that its proofs are sound. So it's interesting, like, but somehow as humans we have some sense of like, I think I'm pretty sane. I think when I do a thing, it's a good idea, like a lot of the time. There's a question of like how, one of the reasons mathematicians were originally surprised by this is that they were like, I think I can use mathematical reasoning to say that mathematical reasoning is good. And then Gödel's soundness theorem is like, well, in a certain sense you can't, and in a certain more general sense you can't. Maybe there are other ways that you can, and like coming up with ways in which a formal system can say that that formal system is trustworthy or sound in the sense of not deriving falsehoods is like hard. Yeah.
So for the first three bullet points there, it's kind of obvious why you want those things. Can you say a bit more about why you want them? Was it pretty important that they have?
Yeah, I mean, I might get to it. This is like harder, but it's also very like there's very surprising image stuff. There are examples where I can write pseudocode on a board for a program and ask you what it will do, and it will do very surprising stuff that you didn't expect. And then you're like, huh, I don't want AI to do very surprising things that I don't expect. That's the one sentence version. I might get to it later. Or you can always ask, I'm going to be around all week, so we can just ask me. Yeah. But in general, we got these like philosophical questions, and like at some point, if the AI is going to have them, they're going to be in binary on a computer. And if we want to know that they were faithfully translated to binary on a computer, then we'd like to have some mathematical, statement of them that we can know that we've done a good job of. So I want to give you an example of what I consider like doing a good job, or like a good technical understanding of the thing. So who's heard of second price auctions as a mechanism for options? So, okay, interesting. Damn, I thought this was going to be... Well, second price
I'm
auction
sure people know the idea.
it's where you, like, everyone, like, I'm auctioning off this isopropyl alcohol. Everyone submits a silent secret bid, and at the end, it goes to the highest bidder, but the highest bidder pays the second highest bid for it. So that way, they're guaranteed not to pay. They're guaranteed to sort of make a profit in the sense that if I bid 100 and the second highest bidder bids 90, I only pay 90 for it, so I'm happy by $10 when I get it. This is an interesting mechanism, and it's optimal in this situation that you bid truthfully. It just turns out when you're in a second price auction, if your bids are really actually secret and you don't know what other people are bidding, then you should just bid what you think the thing is worth to you. You bid your indifference point, if that makes sense. Like you being right. And so this is a theorem, and this is used, it's in network routing when like different servers or groups are bidding for access to access to some connection. They can use second price auctions, and the people who were building computer security systems and network systems, they're very concerned. Like, is someone going to build another system that's incentivized to just like game my auction, right? So they want to make the auction such that it's simple for everyone to use. Just say how much you want the connection, and then maybe you'll get it, and then you'll be happy with what happened. And the cool thing is that this has been subject. Not only is it like a theorem that you could read it yourself and understand, but it's applicable, and not only could you understand and apply it, but other people have been understanding and apply it since 1961. So you can be extra sure that if there are issues about it, they're now on the Wikipedia page for Vickery second price auction. I think this is a great state for a sort of optimality result to be in. It is something that's been around for decades.
Just very briefly, like the other things are, it's very efficient to run this. So you want to decide who to give the thing to, like who to award the good to, like the isopropyl alcohol. You just see who bid the highest bid. So you just look at all the bids and pick the highest one. So you can run the second price auction like very efficiently in practice. So Google sells ads using second price auctions. They're a little more complicated, and I think there are like millions of auctions happening like every hour, maybe every minute, like live with computers doing the bidding. So this is something that's like it's also like very robust in practice because it can actually run efficiently in the world.
Yeah.
Not merely like in theory this would be good, but it would be really slow.
Yeah, and that's important because we want things that are not just theoretically good, but which can actually run in the world, and that will be useful to the people in 2060 who are turning on their AI. Another example is like Nash equilibria. It's a concept in game theory. Who's heard of Nash equilibria? Yeah, Nash equilibria, super interesting concept. When a game has one, for example, when a game has one Nash equilibrium and the equilibrium is like good, then that's probably a game you want to run. It's important to mechanism design, and it's great that it has this like formal definition. Like you've got formal definition with like what's a player, what's a game. It's an ordered, it's an ordered pair. Functions with a function. It's a set of ordered pairs. It's all very clean, and people can prove theorems about it and like make examples that like support it. Understand what supports it for decades since 1951. It doesn't matter what the definition is. The point is, this looks like Wikipedia, right? It's from.
You even have to edit.
Yeah, exactly. Yeah. So that's why I let you edit in. It's like I don't want you to read this. I want you to notice that it's from Wikipedia, and it's been there since 1951 when Wikipedia was invented. Likewise, classical game theory has a very clear concept of what a game is. There's an agent, there's a game, can optimize over things it does in the game, there's another agent. Miri would like to get to that state for a more interesting situation that an AI can be in. So AIs are not faced with classical game theory. AIs are faced with a situation where there's some environment, namely the universe, which includes inside it the AI, which maybe has some utility function or other kind of objective function that it's trying to optimize or act according to. And then the environment or the universe makes some calls to the AI at certain times. And I literally mean the environment is like the laws of physics here. Like Schrödinger's equation follows a computable law. So the AI can like notice that it's inside in some sense a computational process. It can notice that that process is making several calls to it. Like we might call an AI several times. We might have several copies of an AI, so the AI is going to turn up several times. And this is very much not a standard game theory situation. Standard game theory does not deal well with situations where you're playing with copies of yourself. For example, you heard of the prisoner's dilemma? So when you're playing the classical game theory, Nash equilibrium in prisoner's dilemma is what? Defect, right? However, suppose you're playing prisoner's dilemma against an exact cognitive clone of yourself. An exact cognitively identical room, you're getting the same inputs. Like, what will you do?
Win.
You will win. You will win. You can choose cooperate or defect. If you're playing against an exact clone yourself, you choose cooperate. They choose cooperate. You've got the same inputs. You'll have the same outputs. Very easy to understand that. I didn't explain it in great detail, so you cooperate. And this is like outside the technical understanding of classical game theory. It's not outside the technical understanding of human beings who've done classical game theory. I'm not saying they can't understand the situation, but I'm saying that we don't have a good criterion. Whereas in Nash equilibrium, like, we have a good criterion for what it means to be stable, or we have a good criterion we have a good definition of optimality in bit creative options, such that we can even say that it's optimal to bit truthfully, right? We define this, and then we can say this exhibit this property. There is no, as much as it is easy to start simply reasoning about this situation, we have a problem that, like, there is no, as yet, clear conception of what it is for optimality in this framework of, like, a a process running inside another process that it's trying to affect. It seems like a very simple thing, and your intuition is that it is as simple as these other things, and in fact it is, but, like, it took work for those Vic reaction people to, like, come up with that. And it took work for Nash. And I think similarly it takes work to turn possibly as simple a thing into as clean a thing, as clear an understanding as those other technical things. So that's about as far as I will get during this hour, but this is an example of the type of thing that is not a technical problem and needs to be, in order for us to say what it means for it, even say what we want when we say we want the AI to be doing a good job. And there are lots more interesting things, but I think I'll just have to call it a day. So indignation bot is an interesting. Maybe you can, if you Google indignation bot, you might find an interesting example of a program that, for reasons of Gödel-like stuff, does stuff really different from what you would expect it to do. But anyway, I have a bunch more slides. I'll talk about them if you ever want offline. Cool. Thank you.
Okay. Thank you.
Oh.